Hey guys, today we're going to talk about spread and box plots, but nobody calls it spread. What they call it is measures of variation. Variation is how far do things vary, okay? So these are values that describe the spread or, here's a fancy word, distribution, so how things are doled out of a set of data. Okay, and when we're doing this, we're distributing, we're talking about data is separated into equal-sized groups. So the same amount of data is in each of the groups that we're going to create in these distributions, okay? So there's two major things we're going to talk about. The first are quartiles. So this is talking about the groups, and that is data is grouped into 4 equal-sized groups. Now, the second one, so quartiles deals with that distribution of data. The other one that deals with spread, so this is about spreading, but here's the real one about spreading, is range. Now, you guys have done range, and range is simply describes the overall spread of data by subtracting the least value, so the smallest number in the set of data, from the greatest value, so the largest number in the set of data. Okay, and then I'm going to bring in one more word that also can affect the range, the spread of data. It would be outlier. And we talked about him before, but we're going to talk about him in a different way. When we were talking about outliers before, let me just write down the definition. It's a value from the data that is either much larger or much smaller, than the other values in a set of data. Okay, so when we talked about it in the first video this week, it was more of a kind of an eyeball. Do we see something that's going to make our data look weird? Like in the problem we did in class today, it was that making $80 for babysitting when most of her babysitting was between 10 and 20. Okay, and then that outlier had an effect on the mean, saying that mathematically she was paid $24 every time she babysat on average, and that really isn't true. Most of the time she was between 10 and 20. So it can inflate or decrease what the mean looks like. Okay, now I'm going to come back to outlier once we talk about another subject. So that you should be about halfway down this page, so I'm going to go to the next page, and we're going to talk about this key idea called the 5 number summary. So we're going to use 5 key values from a set of data to help us deal with this notion of spread and distribution, this variation, okay? And the thing you have to remember is the thing we talked about also with mean, median, and mode. You need to make sure that when data is in order from least to greatest, you can find and here we go. So I'm going to label out all these things, and then I'm going to go back and we're going to put in the order that I would find them. So first item would be the least value or minimum. It's more of a more mathematically accurate term. Then we're going to look for the median of the first half is called, oops, let me put it this way, the first quartile. So the first quartile. Now he uses this symbols, Q1, so Q sub 1, that's your first quartile. And this is actually a median, but it's the median of the first half of data. Now, only applying once your data is in order from least to greatest. So in order to figure out where the first half is, you got to find where the median is. So that's going to be another number in your sequence. So it's the median of all of the data. And some people do refer to them as the second quartile, or Q sub 2. Then we're going to find, if we have a first quartile, we should, or median of the first half, we have to have a median of the second half. So that's going to be the third quartile. Now the reason why he's third is because remember the median is the second one. So he's Q sub 3. So he's the median of the second half of data. And last but not least is going to be the greatest value in the data. And he's known as the maximum as well. Okay, now what's my order of finding each of these? First, I would find the least value. Second, I would find the greatest value. Why? They're just at the ends. It's super simple. Then the median. I got to know the median before I can figure out where is my first half versus my second half. And then I find my first quartile and my third quartile. Okay. Now, more ideas about spread are going to be the interquartile range. Inter between, quartile, between quarters, range. Interquartile range. So this is the difference, and when I say that in math, I'm talking about subtraction, of the first quartile, let me just write that word, first and third quartiles. Now, mathematically, it makes sense that I'm going to subtract the first quartile from the third quartile because we're going to get a positive answer. Okay, so we write it as, oh here, I'm going to erase that part here. So we would say IQR equals the third quartile minus the first quartile. Okay, now let's talk about that outlier again. There's actually a formula that we would use to calculate if you have an outlier. Sometimes a number looks like it's an outlier, but mathematically it is within a close enough range. So here's what you're going to do. You're going to take the IQR and you're going to multiply it by 1.5. Okay, so what you're going to do is that's just a number, right? You're going to get some sort of number. So if I want to figure out if I have an outlier on the left side, I'm going to take my first quartile and I'm going to subtract the IQR times 1.5. If the number you get actually, I'm just going to leave it like that, and you'll see it in the example. So that would be the first, and then with the upper quartile, you would add it to whatever this number is. Okay, so it becomes a lot easier once you see it in practice. So let's go ahead to the next page, and we're going to actually physically calculate how, if we have an outlier, we're going to also physically calculate the 5-number summary. And the fun thing is there's not a whole lot of calculations. So for me, I'm on my second page, so I'm going to go ahead and retitle Lesson 11-3, Lesson 11-12-3, and this is going to be about spread and box plots. Okay, so I'm going to give you 2 problems on this page. We're going to find the measures of variation. For the data. So when they say that, this is what they're telling you to look for. They want you to calculate range, the 5-number summary, and the interquartile range. Okay, that's what they're looking for when they ask for the measures of variation. All right, so here's your set of data. We've got 64, 61, 67, 59, 60, 58, 57, 71, 56, and 62. So let me count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So I just make a note of that to help me. All right, so first thing I'm going to do is put these in order from least to greatest. So I'm going to look. I have numbers in the 60s, 50s, 70s. So let's start with the 50s. I have 59, 58, 57, 56. So I like to line up my numbers and cross off as I go along. That way I don't forget anything, and then I'll count at the end too. All right, so all my 50s have been accounted for, so then I'm going to look at my 60s. 64, 61, 67, 60, 62. We got a lot of the 60s. So let's see, 60 would come next. Hey, same spot. Then 61, 62. Oh, 59 was the same spot too. That's funny. Then 64. And 67. And the only number that hasn't been accounted for is 71. So there they are, and I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got all 10 numbers. Okay, so now I'm going to do my 5-number summary. So I'm going to label minimum, quartile 1, median, quartile 3, max. Okay, so minimums are easy. It's the smallest number, 56. Max is easy. It's the largest number in your group. Median, I'm going to have to figure out. So with the median, it's going to be halfway in the 10 numbers. So that's going to give me 1, 2, 3, 4, 5. So here's where the median's going to be. Halfway between. So notice you have 5 numbers in front and 5 numbers after. So I'm going to figure out what's halfway between 60 and 61. Now, most people can say, oh, that's 60 and a half, and I agree with you. But if you needed to, you could do it this way, and you get 60.5 or 60 and a half, okay? Now that I have that, I'm going to look for my quartile 1 and my quartile 3. So quartile 1 is going to be the middle of the 5 numbers, so that's going to be the 58. And then quartile 3 is going to be the middle of those 5 numbers at the back end, so that's going to give you 64. Okay, so that takes care of 5-number summary. Now, what we're going to learn next about that is how to then make a graph of this using a box plot. But that's going to happen after I finish these 2 examples. So range, remember, is going to be the max minus the min. So that's going to be our 71 minus our 56. So we rename and we get 15. So our range is 15. Not a terribly big range, but what I like with range is it kind of gives me an idea of what I should count by on my number line if I was going to plot this, what I count by. And because it's a fairly small one, I could count by 1s or 2s. Okay, now we're going to calculate the interquartile range, the IQR. And that's going to be the difference of the 3rd quartile minus the 1st quartile. So let's see, that's going to give us the 64 minus the 58. And that gives us 6. So that's a pretty small number too. So what that basically is saying is that the numbers in this particular set of data are pretty close to each other. They're not very spread very far apart. And then that would be it for this question. So let's deal with the one that asks about outliers. So this one just says find any outliers. And they give us a group of data, 23, 48, 49, 55, 57, 63, 72. So again, I'm going to count how many numbers I have. I have 1, 2, 3, 4, 5, 6, 7 numbers. And I'm going to figure out, in order to do outliers, I need my IQR, remember? So let's see, we have 1, 2, 3, 4. So that's my median. And that's going to split. And I've got 3 numbers in front of it and 3 numbers behind it. So now I'm going to identify my quartile 1 and quartile 3. So quartile 1 would be the middle of the 3 numbers. So that's your quartile 1. And your quartile 3 is going to be the middle of the last 3 numbers. So then we're going to go ahead and do IQR again for this group of data. And that's going to be 63 minus 48. Oops, that's a terrible 5. That looks like a 6. And I get the interquartile range is 15. But that's not what we do about an outlier. Remember, an outlier says we're going to take that data and we're going to multiply it by 1.5. Now, 15 times 15 is 2575, placeholder 5, 1. I get 5, 2, 2. So I get 225, but there's 1 digit after the decimal point. So I'm going to take this number, and I'm not done. I'm not done. Remember I said we're going to subtract that number from quartile 1? So that's how we're going to begin this one. So I'm going to do quartile 1 minus that interquartile range times 1.5. Okay, so let's see what I get. I have 48 take away 22.5. So, oops, sorry, that's a 7. So it gives me a 5, decimal point there. 7 take away 2 is 5, and we get 2. So here's what it's saying. Any number in the data that's less than 25.5 is an outlier. So I look in my set of data to see if I have any numbers less than 25.5, and the answer is yes, 23. So I can conclude 23 is an outlier. So I'm only going to look at the ends pretty much. But I may have more than one outlier on an end. Like if I have like 1, 1, and then everything else is in the 30s and above, then those two ones would both be an outlier. So, or 1 and 2. So then I'm going to try the upper end. And there's no other numbers that are less than that. So then on the other one, I take quartile 3, but I'm going to see if it's larger by that 22.5. So then that's going to give me 63 plus 22.5, and we get 85.5. So this is saying, do we have a number that's greater than 85.5 in our set of data? And the answer is no, because our greatest number is 72. So our answer is 23 is an outlier. Okay, good. So now we're going to kind of focus in on the box plots. So this is going to be again, oops, let's go back to black. My new page, 11-3, 12-3, and now we're going to focus in on the box plot part. So what the heck do I mean by a box plot? A plot is a graph, and it's going to involve a box. So there we are. Now, I am going to tell you, I think I mentioned it, I may not have. One of the things that Common Core did is come in and change names. So this is also called the box and whiskers plot. And you'll see why when we draw it. So we're going to use a number line to show the spread of the data. By plotting, that doesn't, I'm sorry, that looks terrible. Our friend, the 5-number summary. Of the data. That's why we learned that. Okay? So, let's go ahead and plot. I'm going to give you some numbers, and then we'll talk about it in the example. So we're going to draw a box plot. Of the car speed data. I don't know if you guys have noticed this, but if you've ever gone shopping, grocery shopping, like Tiana, I force her to go with me because I don't like her being in the house alone. And but she hates to go into the grocery store, so she sits in the car. But she's in the car with me, and we both noticed how during this time, especially in the first month or so of our isolation at home, our stay-at-home order, people were speeding quite a bit. Yeah, it was not too pretty good. But I think now that more people are getting out on the road, people have been able to get back into jobs. People got stir crazy and started venturing out a little bit more. Like, for us, let's go to the drive-thru at Del Taco. Woo! Big, huge day for us, right? 19, 23, 25, 30. So what we're going to have to do is to put these in order from least to greatest. So I'm going to just kind of abbreviate that L to G. So let's see, we have numbers in the 20s, 30s, 40s, and teens. So we'll start with the teens. So we're going to start with 19. Oh, here, I'm going to put this down a little lower. 19. And then we have 25, 27, 22, 20, 23, 25. Okay, so the smallest would be 20. The next smallest would be 22. Then would come 23. Then we have 25 and 25. And then we have 27. So all I have left are 4 numbers. So now we look for the 30s. We have 35, 34, 30. So 30 would come next, followed by 34, followed by 35. And that leaves 40 at the end. So we started with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I'm going to write that down. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I'm going to write my key ideas over off to the side. Min, quartile 1, median, quartile 3, and max. So min and max are easy. Minimum is 19, max is 40. Okay, and then median. We have 11 numbers, so 1, 2, 3, 4, 5. I have 5 numbers in front of the median, 5 numbers after. Then I'm going to find quartile 1. So it's the middle of the first 5 numbers, which is 22. I'm going to find quartile 3. That's the middle of the second group of 5 numbers, which is 34. Okay? Now, I am going to do range. And the reason why I want to do range is I want to see what I should count by when I do my number line. And my range is 21. So I'm going to count by 2s. That would be a good amount to count by 2s. So I'm going to count by 2s. Basically what I'm looking for is to have about 10 or so numbers, 10 to 15 numbers on a number line. So then I'm going to go ahead and draw my number line. And I'm going to start at 18. I like to start with even numbers. And then 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And I spread those out so that I can write down the numbers where it doesn't look like one big, huge, long number. So now what I'm going to do is I'm going to plot my numbers. I'm going to start with my minimum and my maximum. And notice that I'm plotting it not on the number line. I'm plotting it above the number line. Then I'm going to plot in my quartile 1 is at 22. And then I'm going to get my median is at 25. my quartile 3 is at 34. Okay, so you're like, okay, that's awesome, but how is that called a box plot? Here comes the box. So for the box, you're going to draw vertical lines through quartile 1, the median, and quartile 3, which, by the way, guys, are all all medians. All of those are medians. So vertical, vertical, vertical. And then you connect them up. Now, I saw one of the videos that I attached for you guys to look at, that they do the box, so from the quartile 1 vertical line, quartile 3 vertical line, and they create that rectangular box, and then once they do the box, they draw the line inside. Now, the whiskers, from the old name, are attaching your quartile 1 to the least value and your quartile 3 to the greatest value. Okay, now what's interesting about this graph is, oh, by the way, I'm going to give this a name, car speeds. What would be interesting is to know what the speed limit is, right? Is that I'm breaking these into equal sized groups. So what that means is that 25% of the numbers are between the minimum and the first quartile. So if you notice, there's 2 numbers in that grouping. The next little box that gets formed has 25% of the data in it. And again, there's 2 numbers in it. The next one also represents 25% of the data. And that group has, again, 2 numbers in it. And then we have the last group also represents 25% of the numbers. And again, it has 2 numbers in it. So why are some of the things short and why are some of the things long? So the length of a whisker or box is based on the range for that section. So again, the numbers that are in, let's say, the big long one, go from 25, which is your median, to 34, which is your quartile 3. That is 9, a difference of 9, so a range of 9. But your smallest box, that goes from the lower quartile, this is what I'm used to calling it, quartile 1, to your median, it goes from 22 to 25, which is 3. That's why it's so small, okay? So that's what a box plot does. Now, what gets interesting is that people can ask questions about that, okay? So now, so don't forget, use the title. I'm going to put a little, don't forget the title like I almost did. Okay, so now I'm going to look at this box plot and I'm going to answer some questions. Okay, so I'm going to put them at the bottom. Half of the drivers were driving faster than what speed? So half means 50%, and it says faster than. So they want to know what number were half of the data, so 50% of the data, greater than. So that would be from our median. So we would say 25 miles per hour. Okay. Okay, so that's a question I can answer looking at my graph. What percent of the drivers were driving faster than 34 miles per hour? So I find where 34 is, which is our quartile 3, and faster than that would take it to 25%. Okay? So those are some things that you might be asked to do with the box plot. Not only create it, but then answer some questions. All right, and I have some good videos attached from YouTube that you can watch that as well. All right, good luck, guys. See you on Thursday. Bye-bye now.